Hi, this is Sonia Doucette. In this video, I'll show you how to calculate the concentration of an acid using titration data. This video will show the specific case of a weak acid, strong base titration. In this problem, you have 20 milliliters of phenolic acid being titrated with 0.100 molar sodium hydroxide. The equivalence point is reached at a pH of 8.90 after the addition of 30 milliliters of sodium hydroxide, and you're asked to find the phenolic acid concentration. So in the phenolic acid solution, prior to the start of the titration, you have phenolic acid donating a proton to water to give you a hydronium ion plus the conjugate base of phenolic acid, C6H5O-. So that's your acid dissociation. When sodium hydroxide is added, a neutralization reaction occurs. So sodium hydroxide is a very strong base and will pretty much completely dissociate in solution to give sodium ions and hydroxide ions. So the neutralization reaction will occur between the hydroxide ions that come from the sodium hydroxide and the hydronium ions that come from the acid dissociation reaction of phenolic acid and water. So what you'll have is hydronium ion, one hydronium ion plus a hydroxide ion giving you two water molecules. And what you can see from this equation is that for every mole of hydroxide or sodium hydroxide that's added, 1 mole of hydronium ion or 1 mole of phenolic acid will disappear. Given this information, you can figure out how many moles of hydroxide have been added when the equivalence point is reached. So you know that the concentration of the sodium hydroxide solution you're working with is 0.100 molar. And because for every mole of sodium hydroxide you also have 1 mole of hydroxide ion, you can say that the concentration of your solution of titrant is 0.100 moles of hydroxide per liter. And at the equivalence point, you've added 30 milliliters of sodium hydroxide. Converting that to liters, you have 0.030 liters. Liters will cancel, and you're left with moles of hydroxide ion, and that is 0.003 moles. And because of this neutralization reaction, you know that there's a 1-to-1 molar ratio between the hydroxide ion and the hydronium ion. So also at the equivalence point, you know that 0.003 moles of hydronium ion have been neutralized. Now that you know that, you can figure out the concentration of phenolic acid, because for every mole of phenolic acid that dissociates, you get 1 mole of hydronium ion. So what you can say is that you have 0.003 moles of hydronium ion per volume. So you want to use your original volume here because you want to know the concentration of phenolic acid. So you use the 20 milliliters, you have to convert that to liters. You'll get 0.020 liters. You multiply that by the conversion factor you know that will get you from hydronium ions to phenolic acid, and it's a simple 1-to-1 molar ratio. For every 1 mole of phenolic acid, you have 1 mole of hydronium ions. Moles of hydronium ions cancel out, and you're left with moles per liter of phenolic acid. When you do the math, you get 0.15 molar, and that is going to be your concentration of phenolic acid. So here I've showed you how to solve for the concentration of a weak acid using titration data.